Setup job screen. This is where we tell the machine what material we're cutting and what thickness. So in the top right hand corner up here we've got thickness 10mm, so if we want to change that we just tap on the box, type in a new thickness. This shows us the range we can cut at this particular current on this particular material. So we can toggle between different materials: mild steel, stainless steel, aluminium. Other is there really to allow you to put specific materials in, such as brass or whatever. So we go back to mild steel. Now at 70 amps, this is a Chibora IQC 130. At 70 amps it will cut 3mm up to 20mm, but the 20mm speed is really slow, 280. So you wouldn't want to cut, so what you want to do really is cut in somewhere in the middle of the range. So 70 amps would be ideal for 8mm. 110, if we went to 110, that would still be okay. 130, we're starting to get a bit fast now, 3.2 meters a minute. If we do it at 40 amps, it can actually cut that, so this will give us an indication of where we should be in the range. The choices for cutting these and which current to use can be dictated by a number of things, one of which is what consumables do you have available in your consumable box, what consumables are in a torch at the time, can you be bothered to change them, or down to quality. Generally speaking, the lower the current, the better the quality is going to be, because the machine's going a little bit slower. So we could cut our 8mm at 130 amps, that'd be going to 3 and a bit meters a minute. If we cut it at 70 amps, it's going at 1.5. If you're doing a lot of something, you weren't too worried about the overall quality, then you might want to go for a higher current, so it cuts faster, so you've got less time processing. Extra information on this screen here is we can see the picture of the consumables, we can see the numbers of the items, and as we change current we can see those numbers will change. In this case it's just the nozzle, so this is a 2733, or a 70 amps is a 2732, or a 283 number there. Other information on this screen is nesting. We've shown how we can do nesting. Plate align, you'd use this feature if you cut a bit of heavy plate, and we can use the torch or the laser to measure the angle of the plates and slew the program. It's telling us here that super hole, this is hole processing, it's doing that automatically, that's on. Another button of use is save data. So if you're doing a thickness that's not in this scheme here on the left hand side, you can type the material thickness in there. So we'll just probably can't get it, but we'll just pretend with a sheet of 7mm, for example. So 7mm doesn't exist, so it defaults to the nearest. This cutting speed would somewhere between 7 and 8, so probably about 2 meters. So we press save data, because it sees there isn't a 7mm, it'll create one, and we can type our speed in 2000. Enter. The rest of these numbers are going to be about the same. Save settings. It'll then have a think about it. It'll then create a 7mm setting in there. Say 7mm is perhaps a silly size, but it gives you the idea of what you can do. And you'd use that on the other button as well to create your own specific setups. So that's save data. We can delete that if we don't want to have 7mm. Now that setting's gone. Other stuff we can do in here, if you're cutting thick material, then you might want to raise on pierce. So what can happen when you cut in thick material is you get quite a big slag pool build up, and what you don't want to happen is the torch to go and pierce, then stick its nose in the slag pool. So we can, once it started to pierce, we can then get it to raise further. So you maybe type a 2 in there, raise on pierce for 2mm for maybe a second, and that will mean it's moved away from the weld pool, the slag pool, before it drops down. And there's descriptions on here on the left hand side of how all this lot works. Next. So that's basically the setup job screen.